Successfully managing construction projects comes down to 4 simple steps: define, prepare, implement, and complete. This framework takes us from tendering and bidding through to contract completion, achieving our 4 objectives: completing the contract scope, under budget, keeping our client happy, and fulfilling our ethical responsibility of making sure that nobody gets hurt. But first, what actually is a framework and why do we need one? Well, if we think about it, if we wanted to build something perfectly, we wouldn't want a framework, we'd want a set of instructions. Something that told us exactly what to do and in what order. But instruction manuals for construction projects don't exist. And the reason that is because every project is different and unique. Nobody has done exactly what we're trying to do, so nobody can tell us exactly what to do. At face value, 2 projects could seem absolutely identical. We could be building 2 roads, each with 3 lanes that have street lighting and landscaping and a concrete median barrier between. But the reality is the projects are almost certainly going to be completely different. The weather's different, the location's different, the ground conditions are different, there'll be different in-ground services, there'll be different stakeholders, and we're going to be using different subcontractors. While the physical product might look exactly the same, the 2 projects are going to be completely different. So while all construction projects are different and no one can give us a set of instructions to follow, construction projects do have similar characteristics and repeatable patterns. So that's why instead of a prescriptive set of instructions, we can use a framework that gives us a way of organizing our thinking and following repeatable steps at different stages. And that at its core is what project management is. It's a framework for delivering projects. But while most project management textbooks are hundreds of pages long and project management courses can take 1 to 2 years, I have a simple framework for how I think about managing a construction project, and that is to define, prepare, implement, and complete. This framework works for both construction contractors who are managing a project that they've quoted to deliver and want to maximize their revenue and reduce their costs, but it also works for project developers and owners who are managing their capital works. To make things simple, I'm going to talk from the perspective of a construction contractor when I go through this framework. However, if you are working for a project developer or owner, simply substitute when I'm saying client or head contractor with project sponsor and project requirements. So this is the framework we follow if we want our projects to end up successfully, not like this poor person assembling their IKEA furniture. So first part starts with, what are we trying to achieve? I already spoke about this briefly in the introduction, but really I think all project outcomes you can fit under these 4 headings. The contract scope, delivering what was promised, what we were required to do, finishing the works under budget, spending less than what we estimated it would cost, having 0 incidents, again, our ethical responsibility that nobody gets hurt and we do no damage to the environment, and that we also keep our client and stakeholders happy. At the end of the project, they're satisfied and happy with what we've done and how we've worked with them. So the obvious question to this is, what about time, quality, and these other domains of project management? To me, they all fit under these headings. The only reason we care about time is because it has an impact on cost and keeping our client happy. The only reason we care about quality is because it has an impact on successfully completing the project scope and doing so without too many defects that'll cause us to blow our budgets. When we start to talk about things like time and quality as outcomes, to me, it just confuses what we're trying to do. For example, if we're talking about time, and time is, people always talk about time as an outcome of a project, but if a project takes way longer than, from the perspective of the contractor, if the project takes way longer than what we planned, well, we're going to incur liquidated damages, so it's going to increase our cost, which we care about, and we're also going to annoy our client. But in and of itself, we don't really care about how long the project takes. We care about the impact on our profitability because that's why we're in business. We also care about the impact that has on our client and their perception of us so they can give us more work. So to paint a clearer picture of what I'm trying to talk about, I'll look at this both from the perspective of a contractor and a developer. Again, I'm going to spend the rest of my time talking about this from the perspective of a contractor, but it is good to think about construction project management and the different organizations that use it. From the perspective of a contractor, their whole business model is delivering projects for clients to make money. That means they bill the client for more than it costs them to deliver the work. The contract they sign with the client, the contract scope is what they're agreeing to do, what they're signing a contract to do, and what they're going to get paid to deliver. These are fixed price contracts. So they take on the risk that if it costs them more to do it, they lose their profit margin and potentially even can go over their profit margin. If they're late in doing the works, they'll incur liquidated damages, and they need to keep their clients happy so they can get their repeat work. I mean, some contractors don't do that, but really, if you're talking about a long-term successful contractor, they always get repeat work from their clients, which allows them to charge a premium because they're reliable and good to work with. From the perspective of a project developer, they're not necessarily signing a contract to do works. They're managing a project either internally or externally to generate a positive return on their investment. So for example, a renewable energy developer building a solar farm, they've got some forecast that they think they'll be able to sell the electricity from their solar farm, and they have an estimated cost of doing it. If it generates a positive return on investment, they'll proceed with their project. So their internal client, their requirements for the project will define the scope. For example, the technical team might choose what they want the solar farm to do, what sort of product or inverter to do it. While this budget won't be contractually fixed, one department of the business isn't going to be suing the other one, you can still lose money if you overspend. So if the solar farm costs twice what they think it will, then they're not going to get a positive return on their investment. Finishing late, they won't incur liquidated damages in the same way that a contractor does. However, they will get delayed use of the asset, and they'll also pay more financing costs, or they'll get delayed in receiving rental income if they're building an apartment building. So there are costs for finishing late. But again, go back to this example, time is not an outcome. Time is an outcome so long as it impacts the budget and the perception of the client. So where does our framework fit in? So our framework comes down to 4 phases of managing work. We've got the define phase, which is pre-construction, which is working out what you're agreeing to do. When bidding for work, we're negotiating a contract with a client, we're understanding the terms, we're agreeing to do certain things. We're also setting how much it's going to cost to do it and how long we're going to have. We then sign a contract to say we can do that, and we start planning and preparation. We transform our plan into a detailed set of instructions as to what we're going to do. During the planning phase, we also need to complete the detailed design. Again, depending on if it's a design and construct contract, as the contractor, we might be doing the design, but even if it's a construct only contract, there will always be some sort of shop drawings or approvals phase that fits under design management. We then need to do our procurement. So we need to find our subcontractors and suppliers and sign agreements with them to do the work. And then we also need to set our guardrails. This is our budget and detailed construction schedule that's going to tell us if we're overspending or delayed in doing the work. Having these guardrails is going to be essential in the implementation phase. The implementation phase is when we take our detailed plan that we prepared and we put it into action. Implementation to me is all about following the plan, putting it into action, and course correcting when things change. So because we've got our detailed budgets and schedule, the second we've overspent, the second an activity is delayed, it flags. We know to do something about it before problems escalate out of control. On top of this, we introduce the idea of quality assurance, and we're always going to be testing and checking that what we're building is correct, managing our defects. Just going to roll into the last phase of this framework, which is completion and closeout, where we have to finish the works, hand it over to the clients. We're going to prove we've built everything correctly, make them happy, and then finish and hand over the works. Now, these are phases of the project, but you have to understand that they're not necessarily sequential. Generally, they're sequential. Obviously, we sign a contract before we hand over a project, but they do overlap, and you have to think about a project this way, that the completion phase drastically impacts the pre-construction phase, that these are sequential phases. So for example, if in phase 1, all we're thinking about is winning the work, then we're going to underquote the project. We're not going to pay attention to what's actually required to plan and deliver the works. We even need to be thinking about our completion requirements during phase 1. So for example, say the contract has in it a requirement to hand over spare parts. We have to think about how much these spare parts are going to cost, include them in our estimate. We have to think about the lead time for these spare parts, when we're going to order them. Are we going to include them in our subcontract packages? So even something as simple as spare parts and completions, we need to be thinking about in phase one of the project. So if I use another example of a design and construct contract, typically we think about design management during the pre-construction design phase, doing the detailed design. But really something like design management actually occurs in every phase of the project. In the pre-construction phase, we'll be developing a 10 or 15% concept design. It's going to feed into our estimate and schedule. During phase 2, the pre-construction planning is when we do our detailed design. Phase 3, during construction, we need to manage changes to the design through the RFI process. And then in phase 4, as part of our completion requirements, we'll be preparing and submitting our as-built drawings. So the point I'm trying to make here, and I'm going on about it, is that you can't compartmentalize project management into these neat sequential boxes. This framework is a guide, not a rule book. The phases help to organize your thinking, but you have to be thinking about the project as a whole. All right, let's move into the phases of delivering a project successfully. We start with phase 1, which is defining the scope. This means our goal as a construction contractor is to secure profitable work and to define the terms, conditions, and what we're going to get paid to do it. The inputs to this are going to be the client tender documents, any site information, contract terms. The outputs will be our defined schedule, our estimate, our proposal to the client, and if successful, a negotiated and signed contract that we're happy with. The goal of phase 1 is to win a project that we can deliver profitably. It's not just to win a project, it's to win a project we can deliver profitably. And the strategy we're going to use to do this is to understand the works and follow a systematic approach to understanding and then responding to the client's tender. So this is the pre-construction or tendering process, and it's where we establish what we're agreeing to do. The first step in this process is to first understand the contract scope. We need to understand exactly what we're being asked to quote for and eventually build and deliver. Now, the key here is we want to start with the contract. The contract is eventually what we're going to get paid to do. It's the legal document that sets the boundaries, the obligations, the payment terms, liquidated damages, everything. So contract management is the overarching process. The contract scope is the technical definition of what we're being asked to do, which is defined in the design. But the contract and the scope of works is what sits above the design. And basically, if you don't understand the contract, what the scope of work says, what you're being asked to price and eventually deliver, you have zero chance of being able to deliver the project profitably. Now, there's really two main procurement methods that client use to deliver construction projects. What's referred to as traditional procurement or construct only. So this is where the client gives you an issue for construction drawing set. They ask you to price and then deliver that. The key here is that they're producing the design, and any changes to the design constitute a variation. The second option, which is more non-traditional, more recent, is where the client provides a concept design, a rough outline what they want, and as the contractor, you're doing the design and construction. In this situation, you're responsible for the detailed design and drawings. The key here is as the contractor, you're responsible for the design risk, which as far as construction projects go in terms of managing scope, managing the complexity of the technical solution, managing your eventual costs of the project, design risk is a huge thing to be responsible for. So that's why, look, I know there are different procurement methods like alliances, cost plus, blah, blah, blah. But really, in terms of how most construction contracts are procured, when we're talking about between a project developer and general contractor, it either falls under this traditional construct-only procurement method or the design and construct method. And in design and construct, defining the project scope becomes much more complex, which takes us on to the design itself. So the design is the technical description of the work. It's our drawings, it's our specifications that are telling us exactly what to build. These are the drawings that we can look at to work out how big the slab is, the depth of it, the density of steel reinforcement, basically what the product we're creating is. Now, so from the design, and if it's a design and construct project, we'll only be getting a concept design or a rough outline, such as a project specification of what the client wants in this stage. Or if traditional procurement, we'll get an issue for construction design. We then move on to our next stage in the tender process, once we've understood the project scope, is determining our methodology, which is establishing how we're proposing to deliver the project. Now, if you think about it, you can't possibly produce an estimate or a schedule unless you understand how you're going to build something. Are you using in situ concrete, or are you going to be using precast? Are you going to self-perform the electrical works, or are you going to subcontract them? The methodology, our approach to delivering the project, is the key to both our estimate and our schedule. Now, when I say methodology, I mean our construction sequencing, our access and logistics, our subcontract versus self-perform approach, our equipment and methodology, any temporary works we need, and our site establishment and layout. Are we having laydown facilities? What offices are we going to be having? What temporary utilities do we need to provide? This is the key to both producing an accurate estimate and schedule, which is properly understanding how we're going to deliver the project. Once you understand your approach for delivering the project, you can move on to creating your estimate and your schedule. Now, I'm listing these steps out sequentially, but they are iterative. When you go to price the project and develop your schedule, you're going to change your methodology. All these steps feed into each other. If precast ends up being way more expensive than what you thought it would be, you might choose to go to in situ. It's going to take way longer. Again, you might choose to change the methodology. So these are iterative steps. Your methodology is going to be heavily informed by what things are going to cost and how long they're going to take. But fundamentally, you first need to understand the scope of the project. Then you need to understand how you're planning to build it. And then from this, you can create your estimate and your schedule. Now, as a bit of an aside, estimating tends to have this reputation as being a complicated skill or difficult to do. I actually think estimating is really quite simple. The hardest by far construction management skill that I see is scheduling. Estimating, working out how much something costs, is really working out what resources you need and applying rates to it. Obviously, it's a little bit more complicated than that. Scheduling adds this whole element of time. You need to know the sequence that things happen, the way they relate to each other. You want to do enough detail that it captures the overall duration and you're estimating the planned finish date correctly, but you're not getting too into the detail that you're creating a plan that no one will ever follow. I actually think scheduling is by far the most complicated construction management process. Now, so to prepare our estimate, again, we price our methodology. We work out what resources we need to deliver the project. To prepare our schedule, we work out how long each of these tasks are going to take and put them in the correct sequence and order. Now, again, in the same way that these elements will feed into our methodology, both the estimate and schedule will feed into each other. So if we increase the length of the project, it means we're paying for temporary office hire for longer. It means we're paying for staff salaries for longer. So the schedule is actually a key input into the estimate. And again, if you're, on the other hand, if you're trying to get your costs for the project down, you may choose to change the sequence or methodology with which you deliver the project. You may choose to self-perform more things, in which case you need to allow more time to do it because it'll be continuous working of one work crew as opposed to using multiple subcontractors. So again, these two elements feed into each other. Our estimate is going to be a function of our quantity takeoffs, our productivity rates for different tasks if we're self-performing, the material costs we're getting, the labor costs, the equipment cost, any subcontract quotes for packages we're outsourcing to other contractors, our indirect costs driven by the duration of the project, and any risk allowances and contingency. Scheduling is going to be a combination of the activity durations, the resource availability, procurement lead times, the sequencing logic, what inclement weather we have to allow for, and what sort of approvals we need before starting the works. Now, an estimate, a schedule, even a methodology is a prediction of how we're going to the work. That means at this stage of the process, as we come towards signing a contract, we're introducing uncertainty and assumptions into our process. But with our schedule and estimate, we're assuming productivity rates. We're assuming amounts of weather. We're assuming we're going to get materials within a certain lead time. We're assuming certain ground conditions. Some of these risks we can qualify, some of them we won't be able to. So it's important to understand here as we go through this process, as much as we can do complicated things like Monte Carlo analysis and risk analysis, we are introducing uncertainty, and managing risk is one of the key responsibilities that construction contractors undertake. At the end of the day, as a construction contractor, you're providing a quote and signing a contract today to say, I can build this bridge for $5 million within 12 months. So it's important to understand that through this process, we're now starting to introduce uncertainty. And when it comes to signing the contract, we're committing to taking responsibility and accountability for this uncertainty. So when we finally negotiate and sign the contract, if the client's happy with our price, schedule, our proposal, the scope is now going to be locked in. We can't change anything unless through a variation to the client. The schedule duration is now fixed. We're saying we can complete the works within a fixed time frame. If we go over that, we'll incur liquidated damages. The budget or cost of doing the works, assuming the scope doesn't change, is now our problem, and we are responsible for all the risk and assumptions we've made. So step one, we've defined the project, we've agreed to do the works, the fixed works we've agreed to in the contract at a fixed price for a fixed duration. So we've defined what we're going to do, for how much, and for how long. The next step in this process is to prepare. We're going to set up our project for success. This means developing an exact plan of how we're going to deliver the project in intricate detail, but also setting up guardrails that when it comes to delivering the project are going to help us stay on course. The inputs to this process are going to be the secured contract, the tender documents, which will now become project documents as these were attached to the contract, our preliminary schedule and budget we developed during the pre-construction phase. The outputs are going to be our detailed schedule, our exact plan for how we're going to do the work, our detailed budget and cost code set up, our procurement complete, so we've negotiated and signed all our subcontract agreements. Our design is now going to be complete by the end of this phase, and our safety systems will all be set up. The strategy is obviously to manage the design and procurement, then complete our detailed scheduling and set up our budget. Now, so this is the transition phase where we go from our tender submission, our 15% design, our indicative tender schedule and tender estimate, and we turn this into an executable plan. Yes, we are on the hook for the project cost, the project duration, the project scope, but here's how we add detail to this and we turn this tender into an executable plan. Obviously, the point I'm making is we can't actually change our overall cost or overall schedule completion date because those are going to be fixed. During the tender, it would have been a waste of time and money to prepare highly detailed schedules and budgets. So really, we're just taking this information and we're extending it out. The thing is, during tendering is we don't want to spend too much money preparing a proposal for a project we might not eventually do. So it would have been a waste of money during the tender phase to create a very detailed plan. And on top of that, we just don't have the perfect information to complete the plan, particularly if it's a design and construct project where we're only doing the detailed design after contract signing. We can't actually create very detailed schedules and detailed budgets until we do have some form of accurate design. Now, the start of this process is design management and developing the project technical solution. Obviously, if it is a traditional procurement methodology or construct only project, the client will be issuing us an IFC design. However, even if you do get a full IFC design, you will still have some design development to do through the procurement process. For example, shop drawings, fabrication samples, these sorts of things, I would all classify as design development, where we are doing our detailed shop drawings, working out exactly what we're going to procure, and that would still have to be approved by an owner or architect. Now, obviously, if we are performing a full detailed design as part of a design and construct project, the design management portion of this is going to be much more important. We're going to start with our basic concept design, which are the indicative requirements that we priced off at the tender. We then need to engage an engineer or architect team to complete our detailed design. So these are taking all this concept design and working out from basic sketches to working out exactly what we're going to build, how thick every wall is going to be, exactly where every light fitting is going. Then we need to coordinate this design between all the different disciplines, MEP, structural, fit out, services, whatever. Then we need to get this design approved by our client. They have to sign off and agree to it. Then we can begin actually constructing towards this design and we get the IFC stamp. Even under a traditional construct-only contract, you will have some level of design management, and this would come through vendor shop drawings, things like steel fabrication drawings or precast concrete drawings. Now, the key principle I see behind design management is you want to resolve all the constructability issues on the drawings before you get to the project. Again, it's cheaper to fix a design error with a pencil than a jackhammer. Yeah, the design is obviously going to be the basis of everything we do, as it's the instructions of what we actually have to build. The next part of the detailed planning phase is going to be getting into developing our detailed schedule and our detailed budget. Now, I like to think of these two as our guardrails for the project. They're going to tell us when it comes to project execution, have we missed activities? Are we falling behind schedule? Or for our budget, are we overspending in certain areas? The whole purpose of having a detailed schedule and a detailed budget is obviously partly it's instructions and capturing our plan of how we're going to deliver the project so it's easy to follow and communicate. But also it's a way of knowing as we go off track. So our schedule captures our entire methodology. It captures every activity in the project, what comes before it, referred to as its precursor, the duration of the activity based on our estimated resources we're going to apply to the task, and also our successor. After that task is done, what comes next? The key concept to understand with scheduling is the critical path, and in my experience, most people use the term incorrectly. They throw it around everywhere. The critical path is the series of activities that, if delayed, delay project completion. So if you look at this simple diagram of a project schedule, you can see the activities in red, the way they're sequenced. If any of these activities push out, it's going to push out the finish date. These activities in green that aren't linked in that series of tasks, you can extend those activities and it's not going to extend the finish date. So the red activities are the critical path. The green activities have some level of float associated with them. Again, if you can delay an activity and it doesn't impact the completion date, by definition, it's not on the critical path. To put together this schedule, we need to have a really good understanding of the methodology. This means understanding the lead times for everything, procurement, fabrication, approvals by the client, the entire design development process, and any completion, commissioning, handover activities. All of that, not just the construction, has to be in our schedule. Now, when these schedules are done well, again, they are instructions of how to deliver the work, but they also immediately flag when things aren't going right. Say, for example, we know our structural steel has a 16-week lead time and our installation, which is on the critical path, starts in week 20. If we know from this that we need to order the structural steel by week 2, if we know the shop drawings need 2 weeks to get approved, we know that if we haven't submitted the shop drawings by the end of week 2, we're already going to delay our completion date. And that is the power of correctly linked schedules. You know very early on when something is going to go wrong. Now, in the same way we're going to develop a much more detailed schedule, we're also going to create a much more detailed budget. So to be clear, an estimate is not a budget. An estimate is a way of compiling all of the project costs, but it's done with the ease of pricing accuracy. It's not done to track and control expenditure. For example, when you're pricing a project, say you're pricing a concrete project, you might include formwork in every line item of your project, but in reality, you're just going to place one order for all of the formwork for the project, the start of the job. In that situation, I think it's much cleaner and easier to track if you have a material budget called formwork material that applies to all the activities. When you're estimating, you want to allow for formwork for each of the tasks. It's hard to just make a bucket allowance for formwork project. When you're talking about setting up a budget, you want to allocate your budget in a way that it makes sense with how you're purchasing, how you're spending money. So for example, we know when we're ordering formwork, we order this amount and we go over what we've allocated for it, we're flagging a budget overspend. Now, again, it's important here to understand the relationship between time and cost, to understand our direct costs, which will be mostly time independent tasks, which are going to be a function of our labor, materials, and subcontract costs. Also understand our indirect costs, which are going to be driven by the project schedule. Again, longer project means higher indirect costs. Now, I don't want to keep going on and on about this, but the true value of detailed schedules and detailed budgets is you set up guardrails for how to deliver the project. You know whether you're overspending at the 15% mark rather than the 95% mark, where you can still do something about it. Now, the next key thing we need to do in our pre-construction phase is our procurement, finding our subcontractors and suppliers who are going to be doing the work. The procurement process isn't rocket science. It starts with packaging up the works. We need to take our entire project scope and break it down into all the packages we're going to procure from the market. Goal here is we don't want any gaps between these different trades. Scope gaps means variations later down the line. Each package, we're going to have to then prepare a clear scope of works, put together the relevant drawings, specifications, and schedule requirements. My litmus test for is there enough information in a tender package is you have all the information you would need if you were pricing that package of works. The key driving point for when we can actually start putting together these packages though is going to depend on the design process. Again, if it's an issue for construction design, it's traditional procurement and we can start this the day we sign the contract. But if we're waiting for the design to develop sufficiently, that's what's going to be driving this start date. We then want to get multiple quotes for each package of works. That means sending it to 3 to 5 qualified subcontractors who any one of them has the correct safety record, quality record, capacity, financial capacity to deliver the project. Any one of the people we'd send the package to should be able to do the work. This is critical because what I often see is people sending it to 3 random subcontractors with one subcontractor that they want to do the work and the other 2 aren't actually qualified. If you're doing procurement properly, you need to get 3 to 5 qualified subcontractors to price it for you because that's the only way you're going to leverage market competition correctly. Now, then once you send them the documentation, you need to manage the tender. You'll go back and forward with your subcontractors and suppliers. They'll have questions, clarifications. Basically, you want to keep an open line of communication, but if you've prepared the tender package correctly and cleanly, it should be relatively easy for them to price. Then once we choose a preferred subcontractor, not just based on their price, but on their overall proposal, we then negotiate, sign a contract with them, and then we can start their pre-construction activities, which means having a kickoff meeting with them, working out what they'll need from us to facilitate the works, then getting all their shop drawings, quality documents, safety documents, all approved so they're ready to go when we need them. Now, also in this pre-construction process, we want to consider our safety planning. Again, safety needs to be embedded into our plan. There's no point thinking about safety as site inspections when we're starting the work. Actually, assessing risk and managing risk through this entire process has to be a core part of our planning. If we know before excavation, we need to properly identify all of our services, we should factor that into our schedule. If we know that before setting up a crane, we need to build a proper crane pad and get a temporary works design for that. Again, all these activities should be on our schedule. We should be considering them early on to effectively mitigate any risks before the work starts. Okay, so we've got our detailed plan, our budget, we've completed our design, we've signed up our subcontractors and suppliers, and we've considered the risks and safety associated with doing the work. We're now ready to implement and execute the plan. The goal here is simply to follow the plan we've created and then identify and correct any deviations. The key input to this is going to be the detailed plan and guardrails we set up in phase 2. And the output is the correctly completed project on time, on budget, and with 0 harm. Strategy is insanely simple. We're going to follow the plan we've created. We're going to track what's happening carefully. The second we go outside of our guardrails, the second an activity slips or we're overspending, or we can forecast we're overspending, we're to course correct. Then we need to manage change because change will happen on that project. And we also want to report on performance. The implementation phase, we're spending money to get work done. This is where our plan meets reality. Now, a lot of project management courses don't talk about this concept, but to me, it's mind-blowing that they don't, as it is the fundamental part of this process, is implementing the plan and making it happen. This basically means you communicate the plan to the people doing the work in a clear, concise way. You follow up to make sure they're actually doing it, and then you make sure it happens with no excuses. Now, this is probably the part I hate the most about construction in general, is that sometimes it's just a brute force game. For example, say you've got a concrete pour scheduled for tomorrow. The batch plant where you're planning to order the concrete from calls up the night before and says they've got a breakdown, so they can't fulfill your order. As we all know, this is construction. This stuff happens every single day. The solution to this problem isn't anything smart or fancy. You just have to call 15 other batch plans till you find someone who can fulfill your order. This is the crap part of construction. Plans are great, but when your plan meets reality, things change, things will happen, things will go wrong, and you just have to make sure things keep progressing. Suppliers will let you down, the weather will change, equipment will break, some contractors won't show up, materials will arrive that are damaged, and inspectors won't be available where you want them. Basically, you just have to learn to do everything in your power to consistently make things happen. Now, the key here is following the original plan. The original plan is your baseline, but we all know things are going to change. So what happens when something changes? You need to identify it immediately using your guardrails. You need to understand the impact, find a solution, implement the fix, and then update the plan. The plan isn't meant to be something you create during the pre-construction phase, then refer to every so often to the end of the job. It's a living document. It needs to be updated as things change, as new information becomes available. Now, we track and manage our performance using our guardrails. This is our schedule and our budget. For example, here is an example of a construction budget. Again, you can't even see the detail, but you can instantly see the cost codes where there is an issue. The way we identify these issues is one, having our guardrails, but also tracking what's going to be happening. Every week, as a minimum, we should know, are we hitting our milestones? What percentage complete is each task? Every day we're working, we should be measuring how much work's getting done versus how much we're spending. What materials are we buying? How much are we spending? And then we also want to apply the same philosophy to our safety by tracking key safety metrics, monitoring site performance, and also our quality. This is where we start to check and verify that things are being done correctly, which I'll talk about a bit more in a second. Now, the power of this is we have an objective way to track whether the plan is being implemented correctly. Say, for example, we plan to complete 50% of our foundations by the end of week 3, spending $250,000. So our actual progress at the end of week 3 is we're 35% complete and we've spent $225,000. We can see from this that we're behind schedule. We're at 35% when we should be at 50%. And we're also over budget per unit of work we've completed. We spent $225,000 done to get 35% when we should have only spent $175,000 if we're going to hit our $250,000 by the time we're 50% complete. Again, the power of this is we have objective numbers. These are going to be flagged with a big red mark in our budget and our schedule, and we instantly know that we've got to do something about it before we get to the end of it and then realize we've blown our budget. Now, when we spot the variance from our guardrails, we need to diagnose and act. For example, say our concrete productivity is 20% lower than we expected. First question asks you things like, is it on the critical path? If it's got float, maybe this isn't necessarily going to be a problem. Subsequent trades going to be impacted? Do we have to update our subcontractors? Do we have to change our sequence going forward? We can look at why productivity is so low. Is it because of poor planning, or is it because of the weather and site access? What can we do about it? Can we work weekends? Is it worth working weekends and spending extra money on overtime if it's not a critical path activity? What's the cost of fixing it? And can we make up time elsewhere? Really, again, it comes down to having these flags from our guardrails, but then also being able to properly understand what's happening and why. Now, throughout execution, the key thing you're going to have to pay attention to is the critical path. I've already discussed what this is, but it is the series of activities that, if delayed, delay project completion. When you see a schedule like this, you see the red tasks, you see the green tasks, you can see that that task is critical path, that task is critical path. Those are the ones affecting the completion. Now, some of these other tasks probably have very little float. It's also important to be aware that activities with very low float near the critical path, I would almost just call them part of the critical path, because our schedule is never going to be that exact that we can categorically say this is the critical path or not. But you instantly know that these activities, if delayed, impact project completion, but a delay to this activity, which has a lot of float, it's probably not a big deal, so it's not worth spending money to recover the time. Now, throughout this other process, if we go back to remembering what our main project objectives are, is we want to keep our client happy. The way we do this is reporting on progress and keeping them informed of what's happening. That's when we get into reporting performance. We're not managing the project in a vacuum. Our client wants to be informed and see what's happening. So being able to take all this data we're getting from tracking performance for our detailed schedules and budgets and aligning all these things together, we want to put it into some sort of simple dashboard like this. We want to generate progress reports, schedule updates, budget updates, any key issues and risks, safety, performance and concerns, and quality concerns. This is going to be important for building trust with our client because we're proactively showing them what's happening. They can go then tell their other stakeholders what's happening. Even if we get the exact same end outcomes, the fact that we've constantly been updating them and showing them how the project is progressing, going to be way happier. Now, quality is an incredibly important part of implementing the actual construction work, and there's a whole lot of complicated definitions for construction quality. I just simply think of it as checking that what we're building is correct. This really has two key benefits. It helps us fulfill our contract obligations. We can provide evidence to our client, our completed inspection test plans and test reports, that we have completed the work correctly. And it also is going to help us to prevent mistakes. We don't want to overcomplicate it. It's really about fulfilling those two objectives. Now, I'll fly through the quality process, but it's actually not that difficult. So the quality assurance process is as follows. First, you want to identify all the inspection and testing you're required to complete. So you're going to get this from the contract requirements, the work breakdown structure, and any applicable codes and standards. These are the required testing you need to do to keep your client happy. You might also choose to add optional testing to help support the second objective, which is preventing mistakes. Don't overcomplicate it. It's either required in the contract or you're doing it to help prevent mistakes. You then draft an inspection and test plan to fulfill this. The inspection and test plan is simply a list of all the steps in the process, from pre-construction, ordering materials, completing the construction works and closeout, and determining against each step what can go wrong, what testing you have to do to prove you've fulfilled the requirements. Then once you've set up your inspection and test plans, you need to get these approved by your client and internal quality assurance team. So you'll send it for their approval. They'll confirm what hold points are required. They're happy with everything. They'll agree on it. And then it becomes an approved test plan, which means that you can begin the construction works. And while the construction works are taking place, you schedule and perform these inspections. Now, biggest mistake everyone makes with quality, and as much as anyone says it, you just have to do this in parallel with the work. If you leave everything to the end of the project, it'll be a disaster. It'll be hell to close out. You have to do this in parallel with the work being performed. As you're doing the testing inspections, any non-conformances that you pick up, you simply add to the punch list, which is a register of everything you have to fix before completing the work. Again, if you do this during construction, it's going to make phase 4, which is closeout of the project, 1,000 times easier. Now, we all know the drawings aren't going to be perfect. There's going to be things people haven't thought about. We're going to come up with better or smarter ways to do things during construction. So that's where we get into this idea of change. No plan is perfect. Things will almost certainly change. Our job is to manage this change, both document it, record it, get approval for any changes we're proposing, and then to also manage the cost and schedule impacts of it. Really, I categorize change into two key areas, our RFIs and our variations. RFIs are when we're proposing to change the design. So we want to change what we're building specifically. So we want to change the width of a concrete slab, we want to change the location of a penetration, we want to change the type of cable we're using. That is when we use a request for information. This is when the design is unclear or ambiguous, the design isn't buildable, specifications conflict with the drawings, or information is missing. To prepare an RFI, all we do is we document the issue clearly. We propose a solution. This is very important. I'll never raise an RFI unless I'm proposing a solution to the problem that I think is the best solution. I would never just blindly ask a design team what to do. I always propose something and suggest something that we think will work. Then you want to get your response in writing and then track the impact of the cost. Now, the biggest thing I see a lot of people doing, which I think is crazy, I don't know whether they do it to prove how much they know, but a lot of people just solve their own RFIs, which as a construction engineer and construction manager, that is 100% not your job to do. So always go back to the designers or the client to get approval for any change, which is the purpose of the RFI process. The other impact of change is going to be through variation. So this will be where our client proposes variations to us, or we have to provide, or we have to manage variations with our subcontractors when scope changes. There's two key types of variations. There's a variation requested where the client or whoever is asking us to please do extra work, which basically means we just have to quote to do the work and we agree on the price prior to doing the work. Then there are variations claimed where we are claiming a variation, or our subcontractors are claiming a variation to us, where they believe something is in and out of scope, and we're going to negotiate with them. The strategy that everyone uses with this is you always want to prove the variation exists first and then price it. Now, all of this work we're doing comes down to managing information, making plans happen, tracking performance, managing quality, processing changes, reporting to the client. One of the key things you have to think about and manage during a construction project is the flow of information. We always run into issues where maybe a designer's communicated an RFI, but no one's actually told the people doing the work about it. Shop drawings are submitted to us, but we never submit them to the client for approval. Budget reports or the correct budget numbers don't reach the project manager, who reports on something else. Schedule updates aren't communicated to our subcontractors, so they mobilize the site on the wrong day. The more you can think about one of your core roles as a construction manager or contractor is managing the flow of information, the better you will be at successfully coordinating work. Now, again, stakeholder management is a core part of this entire process. Keeping the client happy with reports, meetings, addressing their concerns, and proactively managing and communicating variations. Dealing and managing subcontractors, giving them access, aligning them with our schedule, resolving issues, working with the design team to close out RFIs, dealing with third-party inspectors. There's a huge part of this which is just working with other people to solve problems proactively. And again, our ethical responsibility always has to be at the front of our mind, which is to make sure the works are done safely and to manage any risk. Now, the last thing I want to leave you with is this idea that problems aren't the problem. The whole point of this framework isn't to prevent problems happening. There's nothing you can do to prevent that. Trades will underperform, the design will have errors, weather will delay you. All these things are going to happen. It's really just about having a framework to catch these problems fast and to fix them before they cascade. Really, the difference between a successful and a failed project isn't whether problems occur, it's whether we catch them fast enough so we can do something about them. Okay, phase 4 complete. By far the easiest thing we have to do, but the most poorly managed. Every project I've worked on struggles with completion, but it is by far the easiest thing we do. The goal of the completions process is to successfully hand over the project to the client. The inputs to this are going to be the completed construction works and all the compiled documentation, like our QA documents through the construction process, and the output is going to be our client accepting the project, the final payment claim, and the contract closed out. The way we're going to do this is we're going to identify what the completions requirements are. We're going to execute a completions checklist. We're going to deliver the documentation. We're going to manage defects and close this out professionally. Again, completions is something that all projects struggle with, and in my opinion, there's no good excuse for doing this other than everyone just ignores it to the last possible second. So the core message I want to give you and what will solve all your completions problems is you need to start planning for completions in phase 1. You need to start thinking about how you're going to hand over the project before you even sign the contract. So phase 1, you plan and prepare for completions. In phase 2 and 3, you treat them like any other project task, where in phase 2, you add them to your schedule, your budgets, and then in phase 3, you track the implementation of them. Then in phase 4, completions is just tying everything together and submitting it to your client. So, for example, phase 1, we should have started a completions register, which is a list of all the things we need to do at the end of the project to hand over the work. So finishing the physical work is actually only one of the things we would typically have to do. The contract will define everything we need to do to hand over the project. We might have to provide spare parts, we might have to do commissioning, we might have to do training, we might have to prepare an operations and maintenance manual. That should all be captured in a requirements list. Everything we need to submit to fully complete the project scope. In phase 2, we then budget for these items, we schedule them into our program, and we order any long lead items through the procurement process, like spare parts or test equipment. Phase 3, these tasks get treated like any other project tasks. They're tracked, the completion of them is tracked, we have QA documentation associated with them, we schedule our commissioning activities, and we prepare our trading material. Phase 4 is simply just tying it all together and submitting what we've done. So In general, the completions process in phase 4 is just finishing the physical work. So this means 100% completing all our construction activities, completing our inspection and testing, closing out our punch list, any final touch-ups and cleaning, removing any temporary works and site facilities, and demobilizing from site. So that's physically finishing the work so that the end product looks exactly like it should on the drawings. The next part of this is getting together and collating all the documentation we need to submit. So these will be things like all our completed inspection and test plans, our as-built drawings marked up with any construction changes, our operations and maintenance manuals, warranties and certificates from suppliers, spare parts if they're required, and completing any training. Again, the specific documents, what we have to submit, will be detailed in the contract. Now, a big part of this, and something that we'll have to coordinate long in advance, will be any approval and certifications we need for the work. Maybe we need a building or certificate of occupancy. We need approval from a power authority to energize the system. We need any regulatory approvals to the project. Those will all have to go into our documentation project, but those actually form a very large part of the completions project, particularly any commissioning or performance reports, which I'm going to speak about in a second. And then once all this is done and submitted, we can do the contract and financial closeout, which is where we make our final payment claim. The client releases the retention, they close out any variations, and the project can be fully closed out and the contract closed out. Now, commissioning is probably one of the biggest. It depends on the nature of the project you're doing, but increasingly with buildings, anything where there's a lot of services, mech-elec and plumbing, commissioning will be a big part of the closeout phase of the project. Now, commissioning is how we verify that what we built functions as intended. If we think about the design as instructions of what to build, then construction quality is simply checking that what we've built is as per design. But the design is developed based on requirements. So the design captures these requirements. If we're doing a construction quality assurance, all we're checking is that we're building as per the design. We're not actually checking that what we've built matches the requirements. So commissioning, I like this diagram of the systems engineering V because it really helps me think about the role of requirements and commissioning and construction. So we think initially we get our project requirements, which will be things like we want lighting on our freeway, we want CCTV camera coverage, all these things. These then get integrated into the design, and the detailed design is showing us where every single light goes, where the cameras go, blah, blah, blah. Commissioning is then, you can think of it as working your way up the requirements on the other end. So we start by doing, where our construction QA simply checks that we've installed what the drawing tells us. The commissioning process slowly checks that each camera turns on, the camera is correct, that then the light fittings work, that each light fitting obtains a certain amount of light readings. And then we slowly test the entire system until eventually we've checked that our entire CCTV system can be controlled from the operator's control cabin. So commissioning is really validates that the requirements of the project have been fulfilled, not just that we've built as per design. Now, another key part of this entire process is going to be the handover walkthroughs with the owner. This is where we give the owner an opportunity, and we work through this with them, to perform formal inspections, to inspect what we've built, review our QA, and they can prepare their own formal punch list of things that they'd like us to close out to complete the works. So our punch list that we developed through the quality assurance process is our internal punch list. With the client, the handover walkthroughs we complete with them, that will be their punch list with us that forms part of the contract closing. So they'll inspect things, they'll pick up things they don't like, they'll pick up things they're not happy with. That goes on our client punch list, and that we work with them to close these out. And the reality is, even after this handover, once we close everything out, complete the punch list, they've accepted the work, we've done the training, handed over the spare parts. Really, we're not even done yet. Even after handover, all construction contracts have some sort of defect liability or warranty period. We will need to respond to any defect claims. So these are defects that haven't been picked up during the work, but we still have to go back and fix. We also, ideally, but no one ever does this, we want to capture any lessons we learned throughout the execution of the project so we don't make the same mistakes again. So look, These are the 4 phases. Again, it's a guide rather than a set of instructions, and understanding the phases is a way of grouping and organizing your tasks and your thinking. Every project's different. Every project's unique. This is a guide or a framework to understand that will help you deliver projects. So really the guide is just a framework. How well we can follow and implement this guide comes down to our skills. There's really 3 core capabilities I see of being a successful construction manager, being able to reliably deliver projects well. It comes down to your technical knowledge, your communication and people skills, and your ability to manage information. So your technical knowledge, you need to understand what's being built and how the construction process works. You need to be able to read and interpret drawings, so architectural drawings, structural drawings, or electrical drawings, civil drawings. You need to understand the construction methods and sequencing, how we go from these drawings to a finished product. You need to know the different materials being used, the properties and limitations. You need to be able to recognize constructability issues and then understand how different systems interact. Now, this technical knowledge is what underpins every single construction management task. If you don't understand how things are built or the technical side of things, all you're really doing to some degree is data entry or administration. Try to put together an estimate without actually understanding how a project's built or create a schedule or manage a contract. You're completely reliant on the input of others. Fundamentally, to manage any construction project well, you do need to understand construction. So, for example, say we want to do an RFI to change in situ concrete to precast concrete. That's a technical solution. We need to understand how this is reflected in the different processes, how it's reflected in cost, what are the different costly options, how long are different options going to take, what are the safety implications, which contractors do we go to, and how do we scope out the procurement. Really, the impact of that RFI is completely driven by the technical proposal. The next skill we need to master, and this is the one that everyone will tell you, so it's relatively obvious, but construction projects are fundamentally about people, so you need to be able to communicate and work well with people. We're building things for people, by people. We need to work with our subcontractors to get them to commit to a schedule. We're going to need to negotiate variations with the client. We want to value engineer and work with the design team. We want to coordinate multiple trades working in the same areas. We want to be able to effectively address safety concerns. These are all communication and people issues. This means being able to clearly explain what needs to happen and why, being able to actively listen and understand the issues people have, how to negotiate and resolve conflict, how to give feedback and receive feedback, how to run effective meetings, and how to write and communicate effectively. I heard this stat somewhere. I don't know how anyone could verify this or know this, but it was something like 90% of a construction manager's job is communication. And to me, from anecdotal experience, I believe that's 100% true. So if we take our RFI to change in situ concrete to precast concrete, we need to have a meeting with the design team to discuss the technical feasibility and the different options. We need to find suppliers and subcontractors to complete the work to get their input on cost and schedule. We need to explain the schedule and cost benefits to client and management to get them over the line. Again, technical side is one thing, the process side of raising the RFI is another. Communication side is effectively what it's going to help us get this proposal over the line. Now, the third part, or the third skill I think every construction manager needs, and I've never really heard anyone talk about, but I'm becoming increasingly obsessed with this idea ever since I've started playing more and more with AI, trying to get it to do things. It's the ability to manage information. Now, the right person needs the right information at the right time. That is the only way a project can run successfully. A subcontractor needs the correct drawings. If there's an RFI, they need to know about the RFI. Estimators need correct production rates and resource rates to compile an estimate. The client needs to approve completed QA. Information is the bottleneck of all construction projects. So, information management as a skill means being able to set up and maintain project management systems, document control, manage meetings and input from different people, manage different versions of different drawings, create high quality records and track information, and organize project data. Again, I've never really heard people talk about this, but the more and more I think about it, all these different construction management tasks, estimating, scheduling, contract management, you can learn them in 20 minutes. They're really not that complicated. The hard part behind all of them is getting the correct information to do the task. So for example, working through our RFI to change in situ concrete to precast concrete, we need to know the cost of the different options. We need to know the correct resource and production rates. We need to then get supplier shop drawings showing our proposal. We need to know the lead times for the crane to work out if it fits within our schedule. We need to get temporary works designs for a crane pad from the designers. We need to get approval for change. We need to get all these different bits of information to make sure the process can be completed correctly. So that's my very brief overview of construction project management. If you do want a much more in-depth overview of every domain of construction project management, then check out this video. It's my complete guide to construction project management, and it's over 8 hours long.